Let's dive right into this explainer and unpack how artificial intelligence is fundamentally shifting the bedrock of modern entertainment. We are at a fascinating inflection point right now. The modern non-playable character, or NPC, well, it isn't just a static 3D model cycling through a looped animation anymore. Increasingly, the entities inhabiting these digital worlds are driven by complex, localized neural networks and dynamic state machines that adapt to your inputs in real time. So we're going to look closely at what it actually means when the code running the digital ecosystem stops simply executing a linear sequence of instructions and begins to observe, calculate, and actively improvise based on your specific behavior.
And honestly, it begs a pretty profound question. Are you playing the game, or is it playing you? For decades, the relationship between a player and a digital world was entirely one-sided. You interacted with finite state machines and static logic loops. You pressed an input, and the software returned a predetermined output. Once you learned the timing, you exploited the mechanics, and boom, you conquered the system. But as machine learning algorithms integrate deeper into game engine architecture, that system is now watching you back. It's actively logging your habits, mapping your tactical preferences, and even identifying your mechanical blind spots. It completely inverts the traditional power dynamic of entertainment by placing you inside a system that studies you just as much as you study it.
What we are really uncovering here is a massive architectural leap from static environments to dynamic ecosystems. Intelligent play is about entirely abandoning the concept of a rigid play space. Think of a static environment like an old-school theme park ride, right? You're locked on a rail, moving at a predetermined speed, and the animatronics trigger at the exact same millisecond every single time you ride it. An intelligent ecosystem, driven by an AI director, is more like stepping into an actual living forest. The environment responds organically to your specific presence. The weather might shift based on a hidden tension metric, and the virtual inhabitants react dynamically to the specific acoustic footprint of your footsteps.
Okay, let's move into Section 1, the evolution of play.
If we trace the engineering history of digital play, we see a steady climb out of massive developmental friction. The past era was strictly pre-programmed. Every pixel's movement was hard-coded with virtually no deviation. Then, we moved into the transition era, which relied on heavily scripted branching logic trees. Developers literally had to write incredibly dense if-then statements to account for every possible thing a player might do. Like, if the player goes left, trigger an ambush. If they go right, spawn a vehicle. But this hit a severe computational and developmental wall. Hard-coding those branching logic trees became a total resource nightmare, taking up massive chunks of development time just to account for simple player deviations. Now, in the current era, developers don't write rigid scripts. They establish foundational parameters and let AI-driven, reactive ecosystems improvise the moment-to-moment logic on the fly.
There's just a massive gulf between the rigid algorithms of the past and the fluid machine learning architecture of today. We all know the classic trope of the older scripted behaviors. That hilarious immersion-breaking moment where an enemy character gets confused by a piece of geometry and just endlessly, aggressively jogs into a brick wall. That happens because a static pathfinding script broke. Machine learning AI completely solves this by utilizing systems like goal-oriented action planning. Instead of being given a strict, predetermined path to follow, the AI is simply given a desire, like flank the player, and an inventory of possible actions. The system then dynamically calculates the absolute best sequence of steps to achieve that goal based on the real-time physics and geometry of the environment. If a path is blocked, it organically calculates a new one in milliseconds.
That brings us to Section 2, what makes games smarter?
Historically, a gaming console or a PC's processor was locked in a constant struggle just to render high-fidelity graphics and calculate basic physics collisions. The actual logic of the digital world was kind of an afterthought, a lightweight list of chores squeezed into whatever processing power was left over. But thanks to asynchronous computing, neural processing architectures, and the offloading of data to cloud servers, that limitation is completely gone. Artificial intelligence now acts as a dedicated, centralized brain for these digital spaces. This overarching AI director can manage complex logic architectures from a top-down perspective, constantly shuffling resources and generating cohesive, systemic decisions across the entire map, which means those repetitive, easily exploited gameplay loops are quickly becoming a relic of the past.
Let's dig deeper into that in Section 3, the AI gaming brain.
The back-end process making this happen is a continuous, relentless feedback loop. Step 1, the player acts. Step 2, the AI analyzes. Step 3, the game adapts. Say you're navigating a hostile environment and you always rely on stealth, sticking to the shadows, moving slowly, avoiding direct confrontation. The system doesn't just passively observe this, it actively structures the environment against you. By analyzing your success rate and movement patterns, the game adapts its tactical layout. It might seamlessly start generating broken glass on the floor in shadowy areas to strip away your acoustic cover, or it might deploy thermal-detecting drones that specifically counter your preferred stealth loadout. The digital ecosystem is dynamically rerouting its own design to challenge your specific psychological tendencies, and it never, ever stops iterating.
To truly grasp the engineering marvel here, you have to consider the massive volume of data being analyzed through parallel processing. We are talking about countless variables. The AI isn't just updating a spreadsheet of your location. It's simultaneously feeding thousands of micro-variables into localized machine learning models. It calculates your camera drift, how many milliseconds you hesitated before opening a door, the bloat of your inventory, and even the cascading consequences of a moral choice you made 30 hours prior. Processing this infinite web of asynchronous data instantly and doing it without dropping a single frame of your 60 frames per second experience represents a staggering achievement in modern software architecture.
All right, Section 4, Adapting to the Player. The way this processing power physically manifests in your experience is fascinating. Imagine dynamic and shifting weather environments that aren't just cosmetic but actively manipulate the physics engine, triggering a sudden downpour that forces your vehicle to slip and slide, specifically programmed on the fly because the AI director identified you were relying way too heavily on high-speed getaways. You have evolving NPC dialogue and behavior, where characters query relational databases in real time to recall past interactions, maybe treating you with suspicion based on your historical behavior patterns. You also have highly adaptive difficulty levels that invisibly tweak invincibility frames or enemy aggression ranges. Essentially, these are ecosystems that react to your choices. The system acts like an invisible dungeon master, constantly tweaking the dials behind the curtain to keep you in a perfect state of flow.
This fundamentally shifts the cultural and social impact of how we consume this medium. Because, the game no longer just exists. It learns, adapts, and evolves alongside the user. Gaming used to be a shared monolith. If everyone faced the exact same digital challenge with the exact same attack patterns, the community would go online and discuss the exact same universally applicable strategy. It created a universal water cooler moment. But a bespoke AI-driven digital world shatters that shared monolith. Your experience becomes entirely isolated and unique to your psychological profile. The community meta changes because your meta is bespoke. The game becomes a deeply personalized, collaborative partner that yields when you're frustrated and pushes back when you're arrogant.
So where is this all heading? Section 5, The Future of Play.
We are actively moving toward predictive modeling in entertainment. We're entering an era where the game ecosystem might just know your playstyle better than you know it yourself. You might think you're an unpredictable player, making spontaneous, chaotic decisions in the heat of the moment. But a machine learning algorithm analyzing hundreds of inputs per second can identify subconscious behavioral tells that you don't even realize you possess. It knows that you invariably dodge to the left when your health drops below 20%. It knows you hoard specific healing items instead of actually using them. By leveraging these massive datasets, the game ecosystem will soon be able to predict your inputs milliseconds before your brain has even fully formulated the conscious thought to make them.
It leaves us with a thrilling and perhaps slightly daunting realization about the trajectory of our digital spaces. We are building digital worlds purposefully designed to challenge human ingenuity, powered by architecture capable of learning our habits at an exponential rate. We are no longer just interacting with static code. We're interacting with a system explicitly designed to outthink us. So if digital play continues this intelligent evolution, what happens when the game finally outsmarts the player? The next time you boot up a digital world and marvel at just how lifelike and reactive the ecosystem feels, ask yourself, who is really setting the rules of the game?